Very good morning, all. Today we are going to see the fifth unit topic, that is monitoring and control. In that, the subtopic is states of power system operation. The reason behind is when the parameters are being in the normal state, there is no harm to the power station. But if some parameters are slightly being violated, then that gives an alert. And if it is being a very larger level, then that is an emergency. Then if it is going to the fault state, then that is an extremis. So we have to look for the normal state of operation of the power system, but sometimes it will go into an alert state and it will be coming back to the normal state. So those two state movement parameters is allowed, but we have to be very cautious in order to ensure the continuous working of the power system. If it is not noted, then the system will be going to the emergency state. Then the reliability will be a very big question mark. So the reason for studying this topic is already being discussed. The next one is an introduction to power system states. The first one is an power system dynamics. We all know the parameters of the power system is an ever varying one, especially the demand is concerned. It will be an dynamic parameters. In morning it will be in one range, in afternoon it will be in another range, and in evening will be in another range. And also the yesterday's demand will not be same on today, and today's demand will be not as same as the tomorrow's. So the demand is an ever varying one. So for that ever varying parameter only we are working round the clock to give the continuous supply to the consumer to meet out the demand. We are running behind the power system. So for that, the system facing the varying demands, faults, and generation changes continuously. The main goal of the system is to maintain stability and prevent outages. What is that outage? The power failure, which is called as an outage. As we discussed in the previous slide, the four main states, normal, alert, emergency, and extremis, will give a guidance to the operator for suitable action. What are the things to be done in the normal state, what are the things to be done in the alert state, and how fast to be done in the alert state. If it is an emergency state, what things we have to do. Simple overview of this four state is being displayed. As the name applies, the normal state, all parameters will be in the safer limits. Alert, it is a cautioning one. The system is nearing its operational limits but remains stable. If it is not being attended, then it will be going to the emergency state. If it is being attended, then the system will come back to the normal state. So the alert state is one of the important state. So the limits are violated in the emergency state. There the potential instability, and there is a high risk of cascading failures. The last one, extremist state, That is a system collapse, that is a major failure in the power system. So these are all the four states of power system: normal, alert, emergency, and extremis. So the normal state characteristics, as we said, the parameters such as voltage, current, and all the real and reactive powers frequency are within the operating range. No equipment is being overloaded here. The reliability is in high bars, and sufficient reserves are maintained for contingencies. Routine monitoring and preventive maintenance tasks are being carried out in the operator side. So these are all some interesting characteristics and important characteristics of the normal state. The next one is an alert state. The values remains within the limits, but vulnerability increases. It causes the system nearing the capacity constraints. So this alert state can be also called as an cautioning state, because it is giving an signal that the system is going to be in a danger zone. Please take some necessary actions. If it is noted and corrective action is being carried out, then the system will be coming back to the normal state. So the what all the operator response is, it they should increase the reserves, they should adjust the level of generation, and they will look for the reversing of those parameters, that is monitoring continuously is needed. The next one is an emergency state. As we know that the limit is being violated, the limit can be violated in the voltage or current or frequency. There is a high risk of widespread of blackouts without intervention. If it is not attended for a very long time, obviously it is going to be in high risk. The next one, at the risk of instability and cascading outages, because all the parameters are being interlinked. If and also the power system components too. If one failure occur, that will disturb the other thing, and the disturbance will be carried out to the next level. So the cascading failure being occurring in this emergency state. So the operator can go for load shedding, that is turn off the unwanted thing or some kind of planned outage for a particular thing to maintain the load balance, then reschedule generations, all the things to be done in a rapid phase. That is what is mainly needed in this emergency state. Then the next one is an emergency next level state is extremist state. The severity will be very high. The total system collapse. So here we have to note down how worst the case is. The system will be losing the synchronism and it will be going to the an islanding state. So the recovery means it requires back the start unit and the coordination restoration is needed. So the operator should follow the restoration protocol and minimize the damage. If they are not following the protocol, the damage will be very severe. So these are all some transitions between the four stages. Normal state is being triggered by forecasted high load and equipment outage. So normally the toggle happenings between the alert and normal. Worst case, they go for the emergency state and they will be coming back to the alert. But if it goes to the extremis, then the risk factor is very very high, and it also takes a huge money to bring back the power system to the normal state. So the role of power system operators, they have to go for real-time monitoring using the software such as SCADA, PMU and EMS. Good decision making is needed, and they should know the protocols and they should follow the protocols rigorously and strictly, and the communications with other centers in a faster manner and good coordination is needed. So the main key takeaway from this four state is the system security. So the understanding the four states, we can enhance the system security, and also the importance of the four states, and what are the responsibilities of the operators, and how the operator can reduce the impact from occurring the blackouts, and some kind of disruptions will be noted, and the technology such as SCADA or PMU or EMS being playing a vital role to avoid the more amount of manpower deploying. The main thing is it requires a fast recovery and robust grid operations. We have to be ever prepared to face out any faults, and those faults can be immediately restored in a very less time so that the reliability of the power system can be highly increased. So we came to the end of this slide. Till now we discussed about various states of power system and what are the impacts of those four states, and how the power system can be working in a healthier phase in the first and second stage, and what are the corrective actions to be taken in the third and fourth state to bring back the power system to the normal or alert state. Thank you for your patient listening. We'll be discussing another interesting topic in the upcoming video. Thank you all.